Okay, tell me, how was your preparation for quiz 2?
Sir, it's okay. Like, it's not that good, but it's okay.
Sir,
We can
not
say.
like quiz one. Sir, it is not like.
Yeah.
Yes, sir, not that good.
So, where do you feel the difficulty?
Week 7.
Week 7.
Limit continuity. Limit continuity, sir.
Hmm. So, what we do today is we will revise week 7 and 8. We mostly emphasize on quiz 2 question paper. Okay. So, we will revise the most important topics that might help you to solve for quiz 2. So,
Okay.
when we deal with that, if required, we will go and deal other topics also. Okay. So
Okay.
before that, let me share my screen.
Sorry, sir. What did you say?
What I said is today we are going to revise the most important topics that might help you for quiz 2.
Okay, sir.
Okay. Is my screen visible?
Yes, sir.
Most awaiting session. Yes, sir. It is visible.
Okay. So yeah, in the last session you might have revised till week 6. So today I will start with week 7 and we will revise week 7 and 8. Then if there is time, then we can discuss the other topics and other questions. Okay. Shall we start?
Okay, sir. Yes. Yes, please.
Yes, sir.
Is my voice is very low?
No, sir. It's
No,
fine.
so
Okay.
it's good, sir.
So for those who are unable to hear me, I suggest you to have headphones or earphones. Any one of it will be good, I guess. So I will slowly increase my voice. So I have to talk throughout the 2-hour session, right? From now on, if I shout, I may not be continuing the whole 2-hour session. So I will slowly increase my voice. But before that, I suggest you to have some earphones or headphones, something.
Yes, sir.
Okay, we shall start now. So in week 7, we will start with the dealing limit of a sequence. And then we have seen what is the limit of a function. So there is some quick reason of till week 6 contents. I am not going to deal with that, but the most important topics are these things. These are the new things we have learned in week 7. So what exactly is the limit of a sequence? So a limit of a sequence is denoted like this. So the third bracket inside some an. So this denotes it's a sequence of some real numbers where the nth term is actually an. So that is what a sequence means. So, oh, did I said limit of a sequence is this?
Yes.
Okay, okay.
This is limit
No,
of
no.
a sequence.
So before looking at the limit of a sequence, let us understand what is a sequence. So sequence means this is the denotion of a sequence. Within the flower brackets, we will give some term an, which is sequence of some real numbers. So keeping like let's say 1, 2, 3, 4. This is a sequence of natural numbers maybe, and there is another sequence like any sequence. So if you sequence, it's a sequence of real numbers, then that is called as a sequence, like 1, 1.1, 1.2, 1.3, 2.1, 2.2. So this is a sequence.
Sir, any difference between what is the difference between series and sequence?
Series is actually the summation.
Okay.
Okay, we are not going to deal with series in this. Okay,
Okay.
so
Okay,
we
sir.
are only dealing with sequences. Sequences means, you know, the actual English meaning of sequence, right? Keeping something in an order or in a line. Sequence, you can refer it as a line. So
Yes, sir.
so this one 1.1, 1.2. So if you keep it as like a sequence is starting from 1. So this is the first term in my sequence. So this will be the second term in my sequence. This will be the third term in my sequence, like this. So there will be some infinite number of terms in my sequence, and this particular thing is called a sequence of real numbers. And instead of denoting this like this or like this, we simply denote with like this. So if I wanted to denote this sequence, simply I will denote it like this. So the inside term denotes the nth term in my sequence. So inside, whatever inside is there, that will denote the nth term. That means this sequence nth term is n. So the first term is 1, second term is 2, third term is 3, like this. The nth term is n. So if my an is a sequence, if I say an, this flower bracket inside an is a sequence, my nth term is an in my sequence. So that is what sequence means. Now if I have an infinite number of real numbers and kept it in a sequence, I just wanted to look at where my infinity term going to. Like here my infinity term is goes to infinite. So when n is becoming larger and larger, so if your n is becoming larger and larger, or
Divergent.
if I wanted to see the right end terms of my sequence, so this is the left end, right? So it starts with first term, and if I wanted to see the last terms, so depending upon where that last term goes, we will say whether the limit exists or does not exist. So that is what a limit means. As n increases, so if you increase n, that means if you are looking at the uh, rightmost terms, so if you are looking at 100th term, 1000th term, so like this, if your n is keeping on increasing, if the real numbers an, so as n increases, my nth term will be getting on increased, comes if this particular an comes closer and closer to some real number. So for example, if I say I have a sequence, and after, if I am looking at the last terms of my sequence, those last terms, if the last terms comes closer and closer to some real number, some any real number, it may be any real number, then this particular sequence an is said to have a limit value a. So simply, if I wanted to talk in mathematical terms, as n tends to infinite, if my an, this particular anth term, an tends to a, then I say limit n tends to infinity an is equal to a. So I will have a limit value for my sequence. Okay, we will see the examples also. So where my last terms are going to, if my last terms are converging. So if yeah, so if these last terms goes closer and closer to some real number a, then we say this particular sequence is a convergent sequence. So convergent sequence means if a particular sequence has a limit value, then that particular sequence is called convergent sequence. If the sequence does not have a limit value, so when does a sequence cannot have a limit? So there are only three possible cases. Okay. So first case is if n tends to infinite, as n tends to infinite, if my anth term is going to plus infinite or minus infinite, so plus or minus infinite, then we say limit does not exist. And the second case is as n tends to infinite, if my an is tending to more than one real number, like it's not coming closer and closer to one unique real number. If it is going to some two different real numbers, two or more than two different, more than one real number, then also we say limit does not exist. So for example, if I say this is a sequence 1 by n, consider a sequence 1 by n. So 1 by n, how will this sequence be?
It's
So the first
convergent.
term of the sequence is 1.
1,
The second term is 1 by 2,
1 by 3,
1 by 3,
One
1
by
by
1 by
4,
4.
1 by 5,
and so
and
on.
so on. Okay. If you see, as I keep on if I see the last terms here, this will be when 1 by 1 0 0 0 0 0 something like this, and the
Yes.
next number is 1 0 0 0 0 0 0 1. So if I see the value of this, and as n tends to infinite, this particular terms will come closer and closer to 0.
Yes, sir.
Okay, only to 0, unique real number. Okay, it comes only to 0. So now I can say limit n tends to infinite 1 by n is equals to 0. So as n tends to infinite, if an is tending to a, some real number, then I can say limit n tends to infinite an is equals to a. So here in this sequence actually comes closer and closer to 0 as n increases. So I can say limit n tends to infinite 1 by n will be equal to 0. So this is one sequence. So what is if I have given you a sequence minus 1 by n? So now tell me what will be the first term?
-1.
Minus 1. So n is equals to 1 is the first term. N is equals to 2, if you substitute, it will be the second term.
Minus
Minus
1
1
by
by
2.
2, 1 by 3.
Again going
one.
towards the 0.
So it will go, so minus 1 by 5, minus 1 by
Minus of
6,
0.
and so on and so on. If I see the, as I
Zero.
keep on increase
0.
n, yeah, it will go closer and closer. These values in my sequence, these terms will go closer and closer to 0. So
Yes,
again
sir.
I can say that limit n tends to infinite minus 1 by n will also be equal to 0. Okay. Now there is one more sequence, this sequence n. Now tell me, what will this sequence be? What will be the limit of this sequence be? This sequence n.
Uh, it will go up to infinity.
Yeah. So this will start with 1. First term is 1, 2, 3, 4, and so on. If I see,
Integers.
as I keep on increasing n, my last terms will never come closer and closer to some real value. It is actually going to infinite, as we don't consider infinite as a real number. Infinite is not a real number. Infinity is not a real number. Actually, you can see, so 1001, something like 1001 and 1002, these are two different real numbers. And the next term is like 1003, which is very much different from these two. So if I see for infinite also, no terms will come closer and closer to other terms. Other terms are come closer and closer to some real value. It will actually be every time the difference is actually 1 only between two terms. So it will go to infinite. So these type of cases, we say limit of this particular sequence n does not exist. So that's it. That is the first case where one sequence cannot have a limit. So if I keep on increasing my n, if my an goes to plus infinite or minus infinite, so plus or minus infinite, I say limit does not exist. For the second case,
If they share a common difference, then only, right?
if they
They are a common difference. The difference between two terms are common here.
no,
One
not
difference.
even common. No need to be common always. Okay, even if sequence n square. Okay, so what is this sequence? This will be like 1, 4, 9, 16, 25, and so on, right?
It will keep on increasing. It will
It will
never
keep on
tend to.
increasing. It will never come closer and closer to some real number. It will go to infinite.
Basically, divergent series.
Yeah. So these type of sequences are called divergent sequences. Okay. If the limit does not exist for a sequence, those sequences are called divergent sequence. So which are not convergent sequences are called divergent sequences. So convergent sequences means if the limit, if the sequence have a limit, then those particular sequences are called convergent sequences.
Sir,
In the second,
one thing here,
hmm.
1, 4, 9, 16, 25.
Mm-hmm.
These number, we can represent all these number on a real number.
Yeah, you can
How,
represent.
so how can we cannot represent the infinite number on real number?
How can we?
not represent the infinite on a real number.
No, that is why it is not a real number, right?
This is not understand this last number. Why?
You cannot understand this. Which one?
Like if goes to infinite, we
Hmm.
cannot we cannot represent. We cannot say like it's a real number. The how?
Yeah, infinity is not a real number. Okay, this is going to infinite. For in order to limit exists for any sequence, that particular sequence should come closer and closer to some real number. Okay, and infinity is not a real number. So that is why this particular sequence we say limit does not exist. Limit will not exist.
But sir, then how 1 by infinity is 0 if infinity is not a real number? Then if we divide anything by a non-real number, it
You
should give us
you
a value.
you are not dividing it by infinite. Okay, it is going to infinite. It is not infinite.
Is that mean, sir, we can say like if we got infinite at the end and we are approaching to infinite, is that mean the limit does not exist?
Yeah, you are going to infinite. It's not. See, there is
Yes.
no infinite. There is no value that takes infinite.
One more thing.
So infinite means it's like a large number we don't know. We don't even know. So whatever the numbers we know, those all are real numbers. And the left end point of the real line. So this will go to this will and this will. This is a real line. If you treat this as a real line, the right end point is called infinite and the left end point is called minus infinite. These two will not be on the line. So it's outside of the line. So there is minus infinite here, there is plus infinite here, and in between these two there will be real line. And on the real line, whatever the points are there, those are the real numbers. Okay, either you go to minus infinite or you go to infinite. That's it. Other than that, there is nothing like it is taking value infinite. Infinite doesn't have any value.
Got it, sir.
Sir, if a sequence is coming from left, whether left or from right, if it is going to some real number, whether from right or from left, then it will call convergent, right?
Yeah. See, if it is coming closer and whether it is from left side or the right side, it doesn't matter. If the complete sequence is coming closer and closer to some real number and unique real number, only one real number, then that particular sequences are called convergent sequences.
Okay, sir.
Okay.
Okay, sir. Got it.
So for example, you have minus 1 by n whole to the power n. Okay. Or you simply take minus 1 to the power n divided by n. So this particular sequence, so if you see the sequence, if you write this sequence explicitly, this will be like minus 1, 1 by 2.
Ruby!
Sure. Okay. So this will be like first term is minus 1, second term is half, third term is minus 1 by 3 plus 1 by 4. So if you see, if you look at on the number line, it will be like this is 0 and the first term is the minus 1, the second term is here half and the third term is here minus 1 by 3 and the fourth term is here 1 by 4. But if you see gradually here left right, it is coming
Approaching to
closer and
zero.
closer to 0. So therefore this particular sequence has a limit and the limit value is actually equal to 0. So I can write limit n tends to infinite minus 1 to the power n by n as 0. Okay. So even here in this case, it is actually approaching from both left and right. So slowly it is coming closer and closer to 0. Okay. So this particular sequence has a limit value. Yeah. And yeah, let's come back to this. When are the cases like limit does not exist? So one case is if it as n tends to infinite, if an is tending to plus infinite or minus infinite, then limit does not exist. And the second case is if as n tends to infinite, if an is tending to more than one real numbers. So it's like let's say, for example, minus 1 to the power n. Okay. So if I take minus 1 to the power as my sequence, what is my first term?
Minus one.
Minus 1. And the second term?
1.
1.
1. And again?
Minus one.
Minus 1.
Minus 1, 1,
Minus
minus 1,
1.
1, and so on. If you see,
It will keep on
this,
oscillating.
yeah, it is an oscillating sequence. Like it either takes minus 1 or plus 1. So as n tends to infinite also, an will go to plus 1 or minus 1. So two
Yes,
values.
two
It goes to two different values, two different real numbers. So even in these type of cases also, we say limit does not exist. So this particular sequence does not have limit. Does
Okay,
not
sir.
exist.
So that is, suppose we write a quadratic equation x square plus 5x plus 4. In that scenario, I will get the true value of x. So here, limit will not exist.
What is that x square? See,
X
you are.
square, x square plus 5x plus 4.
Okay, you are saying that your sequence is. Let me get some space. Okay, your sequence is something like n square plus 3n plus 5 something.
Yeah. Yes.
See, you see, you write it explicitly in order to understand better. Explicitly means write first term, second term, third term, and see. What will be the first term if you substitute n is equals to 1?
Okay, no, basically I'm not substituting. Basically
8,
I'm
sir.
here going to dividing the middle term and taking common this term and getting the value of n equal to suppose 1 or n equal to 2. There are two roots of n.
Why are
That
you
scenario
mixing up this roots and sequences here?
Okay.
There is nothing
No,
to do
basically,
with roots.
Okay.
These are some real numbers and we are arranging that real numbers in particular sequence. Okay. And these real numbers, if these real numbers come closer and closer to one unique real number, then we say this particular sequence has a limit value. If it is not coming closer and closer to one real number, if it is going to more than one real number, or it is going to plus infinity or minus infinity, then we say limit does not exist. Yeah. So this is about limit and
So that
when will
means you are
limit.
saying if for oscillating sequences also a limit does not exist now.
Yeah, oscillating sequences limit does not exist because it will go to more than one real number. Okay.
Okay, sir.
Yeah,
Sir,
let's see some. Yeah.
sir, a sequence was asked in mock 2 where it was mentioned as a1 equal to 0 and a2 equal to 1 and an as given equal to an minus 1.
Wait. I will come to mock questions while I take examples. I still have examples.
Okay, sir. Okay, sir.
At that place we will discuss. Okay. Let us see this quickly. See this properties. This is just the revision. Okay. We just revise few things and we do examples.
Okay, sir.
Okay. Yeah. So that is about limit, and when limit does not exist, those are the two cases, possible cases. Apart from these two, every sequence will have limit. So these are the only two cases where limit does not exist. Now let's come and quickly see what are the properties of these limits. If I have two sequences and let's say one sequence is tending to A and another sequence has limit value B. So there are two sequences AN and BN, and AN has limit A, limit value as A, and BN has limit value B. Now some operations, arithmetic operations we perform between two sequences. So if I add these two sequences and if I see whether the limit exists or not, surprisingly AN plus BN will tend to A plus B. That means the limit, if I add these two sequences, the limit value of the combined sum sequence will be tending to A plus B. So if I wanted to write in the other way, it is simply saying that as limit n tends to infinite, an plus bn is actually equal to limit n tends to infinite an plus limit n tends to infinite bn. So this is a plus this is b. So the summation of two sequences will be equal to, the limit value will be equal to a plus b, sum of the limit values of these two sequences. Similarly for
But
minus
what
also.
are A and B?
Hmm?
What are these A and B? Are they first term? Because
Not the
A n is
first
the
terms,
nth
the
term.
limit value, the limit value. So an is tending to a. If an, one sequence
The
an is
limit
tending to
of
a,
A n.
yeah, limit n tends to infinite an is equals to a. Okay, this or this, both are same representations. Okay, an tending to a is same as saying that limit n tends to infinite an value is equal to a.
Yes, sir, explain.
Okay, yeah. So even if I take minus, if I subtract two sequences, the limit value of the subtracted sequence will be a minus b. That's it. If I have minus here, I will have minus here. And the product of two sequences is also interesting thing. So it is also the same. Limit n tends to infinite. an bn, this particular new an bn will go to limit n tends to infinite an times limit n tends to infinite bn.
Yeah.
So this is actually a times b. So
A
the
times
product,
B.
yeah, the product sequence, the limit value of the product sequence will be a times b, product of the limit values of the two sequences. And the third part,
Sir,
the
we
third, yeah,
individually calculate the, we have to individually calculate both the end limits, right? For A n,
yeah.
we have to calculate
If you
B
know,
n, we have
yeah,
to
if you
calculate.
know the end limit, the limits of an and bn, then you know the product sequence limit, sum of sequences limit, subtraction of two sequences limit. These all we know. So using these
Multiplying by
properties we
constant.
can find. Yeah,
Okay.
and the third property is if you multiply by constant, the limit value will be c times the limit value. So the same thing, limit n tends to infinite, c times an will be c times limit n tends to infinite an. So this will be c times a. So yeah, so these are important properties. And another property is also something like if f is some polynomial function. Let's say if f is some an square, some function. So if I say f of an is actually an square plus 2an plus 1, something like this. So if f is some polynomial function, f of an will go to, or the limit value of f of an will be f of a. So yeah, even this is also the same thing. Limit n tends to infinite an square plus 2an plus 1. I can write it as limit n tends to infinite an square plus limit n tends to infinite 2an plus limit n tends to infinite 1. So this,
Because of the property 1, right, sir?
yeah. So you can use it like that, and this will be like a square plus 2a plus 1, and this will be f of a. So f of an, the limit value of this f of an will be f of a if an has a limit value a. And there is another property which is log an. So the log of an, if I have some sequence an which has limit value a, log of that sequence is a new sequence, and that particular sequence will go to log a. Okay, what
Okay,
it
sir.
says is limit n tends to infinite log an. You can actually take it like log of limit n tends to infinite an. Okay, this will be log a. So this is a, so this will be log a. That's it. So these are some important properties.
So
Keep
in
in
the
mind.
polynomial, if we have in the denominator we have another polynomial, then
That
this
is that is different, right? So we only said that if f is a polynomial function. So divided by another polynomial is not a polynomial function.
yes.
Okay. So this is
Sir,
only for polynomial case. Hmm.
sir,
Hmm.
in all, we have to take n tends to infinite. Is that?
Yeah. See, that is what it tells us. See, this particular representation, what it means is an tends to a means if I take n tends to infinite, my an sequence is coming closer to a. So that means these both are same.
Okay, sir.
So limit n tends to infinity, an is equal to a. So the limit value of an is a. That is what this tells you.
Excuse me,
Okay,
sir.
sir.
Okay, yeah.
Sir, this function knows n square plus 3n plus 5. Is it convergent or divergent, sir?
You tell me what is this?
I just substituted the values 1, 2, 3. So I got the whole numbers at 8, 15. The difference is very huge.
Okay, it is going where this
Divergent.
will as n. If I keep on increasing n,
Yes, sir.
what will
It
this
move
value
on.
will
It's
go?
move on continuously.
It will go till to infinite.
Yes, sir.
So
So
it
it
will
is
go.
divergent. So then
Yeah.
there's no limits.
Yeah, limit does not exist.
Okay, sir. Okay. Thank you, sir.
Sir,
Okay.
in properties of limits, an by bn is not equal to a by b, right?
An by bn is not equal to a by b. Correct.
Okay.
So
Sir,
that is
then
why that is
one
not even a
example
property.
for convergence, sir. Because whenever I try to do, all the things are coming.
See, 1 by n is a convergent sequence.
Convergent.
1 by n is a
Sir, may
convergent.
I, if
Yeah.
possible?
Yeah, please.
Like any real, if we approach to the any real one value, exact
Okay.
one value, then we can say it is a convergent.
Oh, real value. We want to get real value.
Yeah.
Yes.
As n
But exact.
Okay,
Only
okay.
one. Only one.
Okay, sir. It's clear, clear. Thank you.
Okay. Okay, now let's see
Is I'm
some.
correct, sir?
Yeah, correct. So let us see some standard limits we know. So just now we have seen limit n tends to infinity, 1 by n will be equal to 0. So this is the most important one. We actually use most of the examples actually use this thing. And the second limit is as limit n tends to infinite, n to the power 1 by n will be equal to 1. So just no need to remember also. Just go through this. That's it. And also the third standard limit we know as n tends to infinite, 1 plus 1 by n to the power n will go to e.
Okay, sir.
So this is actually in week 5 professor has discussed this, I guess.
Continuous compounding.
Continuous compounding, he just said about this, and he said that this will limit value will go to e. So these are some standard limits we have. And yeah, most importantly, first one we require to solve many of our examples. Okay, we will take some
How
examples.
second example is how we reach that solution of second example, limit n tends to
Second one.
infinity and to the power.
See, this will be like infinity power 0. Like it is again an indeterminate form which we didn't discuss actually. But this is one standard limit. Okay. Don't just now I said, right, don't focus much on it. These are some standard limits I just gave you, that's it.
See the first one which has 5 stars on it.
Okay. Okay, let's deal some examples on limit of a sequence. So if I have some sequence, let us solve one by one. Okay. So if I have a sequence an and nth term, so we usually give you the nth term. So if an is equals to something like this, what is the limit of the sequence an? So this is how usual standard questions looks like. Okay, we will give you the nth term every time, even in activity or anywhere you can see. So an is given as 6n square minus n plus 4 divided by minus 2 minus 3n plus 2n square.
It will 3.
3.
Okay, how do we solve actually these type of questions?
Divide by n
Actually,
square.
sir, because
Take n square common.
Correct. So what you do is you take out the highest degree power term common from numerator and the denominator. So we need to find limit n tends to infinite an. So that means we need to find limit n tends to infinite 6n square minus n plus 4 divided by minus 2 plus minus 3n plus 2n square. So if I directly take as n tending to infinite, the numerator will go to infinite and the denominator will also go to infinite. So this is like infinite by infinite, and we do. Some people might think that we cannot actually find the limit for this. But in order to solve these things, as everyone know, what you have to do is you have to take the highest power, which is n square. So there are 3 terms in the numerator, but the highest power is 2. So you have to take common n square from the numerator as well as from the denominator. So if we do that, what we will get, if I take n square common, I will get 6 minus 1 by n plus 4 by
4
n
by n square.
And divided by, if I take
2
n square
by
from the
n.
denominator common, minus 2 by n square minus 3 by n
Plus 2.
Okay, so this n square and this n square cancel it out. Now we have something
1
6
by
minus
n is
1 by
0.
n plus 4 by n square. Now you see, as n tends to infinite, where will this 1 by n go?
0.
0. So that is so this thing you have to remember every time. So as n tends to infinite, our 1 by n will go to 0. So this term goes to 0. If 1 by n only going to 0, where will 1 by n 1 by n square will go?
0.
As n tends to infinite?
0.
0.
Yeah, this is also 0.
And
And in the denominator also,
same 0.
this will go to 0.
0.
This will go to 0.
3.
So we are left with 6 in the numerator and 2 in the denominator. So our answer will be 3.
Excuse me, sir.
Right. Yeah.
Sir, if we solve with L'Hopital rule, then answer will be the same. The same thing.
How you are using L'Hopital rule?
No.
L'Hopital is for functions. No, it's not about sequences. It's for functions.
Sir,
Yes, sir.
as in this question, we can also take the limit for single term, like if we take 6 and then minus 1 by n, and it is the same thing that what we did here. Okay.
Yeah. So simply what you can also do is, whatever the highest, no need to do all these things. Okay, I'm just telling you some shortcut kind of thing. It may not look like shortcut, but you can directly get it. So you see the coefficient of the highest power in the numerator. So firstly, in order to apply this, you should have the same highest degree for numerator and denominator. So I have 2 degree in the numerator and also 2 degree in the denominator. So what I can do is take the coefficient of the highest degree in the numerator and take the coefficient of the highest degree in the denominator. That's it. So 6 by 2.
And sir, what if the powers are different of numerator?
What if the powers are different? So what if numerator power is lesser than the denominator power? So suppose if I say a
then limit does
something
not
like
exist.
n minus 4 divided by n square plus 2.
Limit does not exist.
The limit does not exist, is it?
How did we get the...
No, infinity is the limit.
Infinity?
For me, it is 0.
Limit exists 1.
Numerator is more. 0.
0.
It is
0.
0. It is same like that, the below solution.
Okay. So what you can do is, you can actually do like this: n by n square plus 2 minus 4 by n square plus 2. And you take n common from the denominator, and what will you get? N of n plus 2 by n. So this and this will get cancelled. So you will have something like 4 by n square. So this will anyway go to 0.
Yes, sir.
Yes, sir.
Okay. And you have another term like this: 1 by n plus 2 by n. So this will anyway go to 0. 2 by n.
Yes.
If this is going to 0 and this is going to infinite,
0.
And 1 by infinite will go to
0.
0. So this particular sequence will slowly converge to 0. Okay. But what if the numerator coefficient, numerator power is higher than the denominator?
Sir,
What if
infinite.
something like this? Yeah, it will go to
Infinite.
infinite.
Divergent.
Yeah. And
Sir,
don't
but I didn't understand that you said if the degrees are same, then what we did is
if the degrees are same, what you simply can do is you take the coefficients of the highest degree. So numerator mein, which one is the highest degree?
okay, we have to take coefficient. Okay,
Coefficient,
6
yeah.
and 2. Okay,
6
got
and 2.
it. Got it.
Sir,
here also we will do the same thing. Yeah.
So to find the limit of a sequence of nth term means to find the limit at n tending to infinite, not any other number like 0.
No, not any other thing. So for sequences, we only take limit n tends to infinite.
Okay, sir.
Okay.
Sir, I didn't understand what you posted in the chat box.
I didn't post anything. Do we need to remember?
Sir, that's not you, sir.
Sir, in question number 1,
do we need to remember? One second. Do we need to remember the limit of complex sequence involving factorial, nth root, and more? No. No, straight away answer. My answer is no. No need of those. Okay. Any doubt?
Sir, in the first question, do we need to check if there is any common factor? Like,
we need to check
if there is any common factor between the numerator and the denominator.
Not the common factor. You just have to take the highest degree common.
Now, should we factorize and see if something cancels with something?
You can do that if you can.
Is that the first step to check? Is what I want to know.
No. Not
We look for
necessarily.
common factors when the limits are indeterminate form. If we got a real number by putting the limits, then no need to check the common factors and other things like that.
Yeah. So no need of for these kind of no need of checking for common factors. Okay. It might reduce the burden. That's it. But anyway, if a common factor goes off, something there will be remained, right? 3n minus 2 by something like n minus 1 or like this kind of thing might remain. And again, you have to take n and n common out of this, and you have to do the same thing.
Hello.
So no need of cancelling out the common terms. You can actually follow this approach.
Hello, sir. Hello. Sir, I have one question, right? So straight away means blindly, do we need to check? Do we need to take the common of highest degree n square, and just do like this? Means, is there any exception for such type of questions?
No. See, if your numerator degree, highest degree, and the denominator highest degree are same.
Okay. In that case only.
In that case, you can directly take the coefficient of the highest degrees. So
And
6 and 2 you can take directly.
In such question, suppose in such question there will be always one constant value, right?
Of course. Why?
I mean, suppose there is one value that goes to 1 upon infinity or 0 upon 0 like that. So it will never happen, right?
No.
Okay, fine.
Okay, let us come and solve the second question now. So this is some kind of a different sequence. So what it says is, if my n is even, so it will be like 4n plus 3 by 1 minus 4n. If my n is odd, then it takes this form. So for places also it is different. So first term. So when n is odd means the first term is actually odd term. So if it is odd term, it will take like this 4 minus 6 times 1 square. So the first term of the sequence is something like this.
Okay, sir.
So this is the first term, and the second term will be, so when I say second term, my n is 2. So n is 2 means it is even. So
Yes,
then
sir.
it will take this form. So therefore the second term will be 4 times 2 plus 3 divided by 1 minus 4 times 2.
11 by.
So this will be the second term. So the third term means n is equals to 3. When n is 3, n is odd here. So therefore it takes this form now. So n is n3, substitute n is 3, and this will be the value of the third term in my sequence Bn. Now my question is whether the limit for Bn exists or not. If exists, what is the value?
Minus one, sir.
Minus one.
Minus 1, sir.
For
Minus 1.
both odd and even, we get minus one.
Same.
So minus 1 is the answer. Correct. So how we solve it? We take it like two different cases, two different sequences. Okay. So when n is even, we have limit n tends to infinite 4n plus 3 by 1 minus 4n. So what is how to solve this thing? You take n common, or you can take n common. We will get limit n
common.
n of 4 plus 3 by n divided by n of 1 by n minus 4. So this and this will get cancelled, and this will go to 0. This will go to 0.
Minus
It will
1.
be like 4 by minus 4. It will be minus 1.
Yeah.
So when n is even, my sequence is going to minus 1. And you have to compute the same thing for odd also. When n is odd, limit n tends to infinite 4 minus 6n square, 6n square plus 5n minus 9. So what we have to do here now, it is n square and n square. So take n square, pull out n square common. So limit n tends to infinite n square 4 by n square minus 6 divided by n square of 6 plus 5 by n minus 9 by n square. So here also n square will get cancelled. This will go to 0. This will go to 0. This will go to 0. And the numerator is minus 6 by denominator is 6 and minus 1. Correct?
Yes, sir.
Yes, sir. Also use that common, means having the common power there. No? Degree is common, so we can directly use that.
You can directly use that. I'm just following the standard approach. You can
Sir,
directly use that.
suppose when n is even, like then it is getting to different value, and if it is odd, it is getting to different value. Then Bn is not convergent.
Convergent sequence, and we say limit does not exist. Now that, so this is how we check. Now that even in n is even case or n is odd case, we are getting the value as minus 1. That means this particular sequence is actually coming closer and closer to minus 1, even if n is odd or even.
Yes.
So that means the limit of this sequence is coming close. This particular sequence is coming closer and closer to only one unique real number, which is minus 1. So we say limit n tends to infinite, Bn actually equals to minus 1. So the limit value exists because
Sir,
these two values.
Can we tell this sequence is continuous? We have term for continuous in a sequence.
See, don't confuse. We are only in sequences that see continuity, whatever you are talking, L'Hopital rules and everything will come only in during the functions, limit of a functions. So limit, continuity, differentiability, everything is for functions. Sequence, we have only limit. That's it. Nothing else.
Sir, is sequence a function?
Is sequence
A function?
No.
No. So function is a different thing. Sequence is a different thing. Okay. Sequences are represented like this: A n, B n. So in sequences, we have first term, second term, third term, and so on. But in functions, there is no first value, second value, nothing like that. Functions will not have like that. Have you seen any functions like that so far? Talking
Sir,
like
there was a
No, sir.
question. There was a question where the sequence is mentioned in the sequence form a n minus 1 plus n, like that. I cannot find this time this question. I want to try more, but I cannot solve that question.
Which
Where
question?
the limit?
Sir, he is asking the same questions are on the with that mock test.
Mock test. Okay. We will take the mock test question also. Let me complete this. Okay. Let's come back to this. Sequences. For sequences in our course, we deal about sequences. We study about sequences and we study about limit of a sequence. That's it. Nothing else. Nothing more. Okay, no L'Hopital, no continuity, no differentiability, nothing. Even that doesn't make any sense in sequences. So only for sequences there will only be limits. Either limit exists or does not exist. If exists, what is the value? That's it. Okay. What if here instead of 6 it is something like 3?
It will be
Now where this
minus
minus 2.
this will be 3 and this will be 3 and this will be 3 and the value will be
Minus
minus 2. Now you see, when n is even it is going to minus 1. When n is odd it is going to minus 2.
different.
Not converging
Different
to a single
values.
point.
So it is going to two different values. So therefore we say Bn is the limit for Bn does not exist.
Does not exist.
Okay, that is the difference. Okay, but if we give like this, this is how you have to check whether the limit exists or not. If exists, what is the value? Okay, let's come to this particular.
Sir, question here. Since it's for even you have -1, odd you have -2. That's why limit does not exist.
Does
That's
not exist. Correct.
Okay. So in case even odd, if you have two different formula, then the limit should be same for both.
Correct.
Okay.
If the limit is same, then we say
limit exists. Otherwise, not exist.
Sir,
Okay.
in place of even or odd, we can also check for the two values, like if n is 2, if n is 3. Can we check for that also?
See, but it will be difficult, right? Maybe if in the start of the sequences, the values are very far. But as n tends to infinite, the values may come closer and closer to some value minus 1. Okay. Yeah. Okay, let us solve this particular thing. What is the limit n tends to infinite?
0.
0, sir.
Because 1 upon n, whatever it is, but still it is 1 upon n.
Sandwich property, sir.
Correct.
Yeah.
So you can use the sandwich property here. So you see cos n is actually in between -1 and +1 cos values. Correct?
Yeah.
So it will be like -1 less than or equals to cos n less than or equals to 1. Okay. So if we divide it by n and divide by n,
0.
so this particular limit will go to 0. Even this particular limit will go to 0. So this particular limit will also go to 0. Simple.
Yes, sir.
Okay. Even if you don't understand that, you just see numerator by denominator. Numerator value will always be in between -1 to 1. It will oscillate between -1 to 1. But the denominator will keep on increasing and it will go to infinite. So some value, you have some value in the numerator divided by some big value, some very large value very much nearer to infinite. So that will be like something by infinite. It will be 0. Correct?
Sir, can we use sandwich principle to all oscillate function like?
These kind of functions you can use sandwich. Maybe cos n by n, sin n by n, like this.
Okay.
Yeah. Now the final one I have is combination of 2-3 sequences. So we know we have seen an, bn, cn till now. So what will be the limit value
6
of dn? So the limit n tends
Minus
to
3.
infinite dn. What is this? So
Minus
let us say bn has a sequence limit -1. Okay, don't consider that red thing. Now what this will be?
6.
So this will be like limit n tends to infinite an square plus 3bn plus cn. So using the sum of limit. Yeah.
Yes.
So you can write it like this: plus 3 times plus limit n tends to infinite 3 times bn plus limit n tends to infinite cn. Okay. And this particular thing you see, limit n tends to infinite an square will actually go to a square.
9.
So what is the limit value of a?
3.
We have 3.
9.
So it will go to 3 square plus. So this is
3
c
into
times.
-1.
So this will
Minus
be 3
1.
times -1.
Yeah.
Plus
0.
this is cn is 0.
0.
So 9 minus 3 plus 0.
6.
Something like this. 6. Okay. this is how you can directly get the limit of this particular sequence Dn. So this is just the combination of some sequences. Okay. Yeah.
Okay,
What is
sir.
the mock question now? Can I get the mock question?
An is equal to An minus 1. This is question number 4.
Okay, just tell me. An is equals to
An minus 1 plus An minus 2 upon 2.
Upon
2.
2.
For all n greater than or equal to 3.
Okay, for all n greater than or equals to 3.
A1 is equal to 0.
A1 is equals to 0 and
A2 is equal to 1.
1. Okay. Yeah. So in order to solve this, so this is somewhat high, some thinking you should need in order to solve this problem. Okay. If I see just the sequence, okay, let me explicitly see the sequence. What will be A3?
A2.
A2.
This is
Two,
like
sir.
A2 plus A1 by
2.
So this will be like 1 plus 0 by 2. Half. Correct?
Yes.
Yes, sir.
Yes, sir.
Now what is A4? This is A3 plus A2 by 2.
Yes.
So this is
half plus
1 by 2.
3 by 4.
3 by 4. And the next term you see. So this is actually the midpoints. If you clearly see, yeah.
Midpoint.
So A3 is actually the midpoint of A1 and A2. A4 is actually the midpoint of A2 and A3.
Yes.
Understand? If I see it on the real number, so this is 0, this is 1. You see, this is A1 given to you, A2. Now the A3 is midpoint of these two, which is A3 is midpoint of these two, which is half. Now that this is half, now A4 is midpoint of these two, which is 3 by 4. And A5 is midpoint of these two, like this. So it will actually be coming in closer and closer to some value here. This is what we have to find. Okay. It will actually come closer and closer to some value. So therefore, you can visually understand that this particular sequence has a limit. Now let us compute the limit. Let us try to compute the limit. So we need to find limit n tends to infinite an, correct, which is equals to we have to find that. Okay, let us find that. So you have A5 is equals to A4 plus A3 by 2, like this. What is an?
An minus
An minus
It's given.
1.
An minus
1 plus n
an
minus 2.
minus 1 plus an minus 2 divided by 2. So what I will do is, I will add these values A3 plus A4 plus A5 plus A6 plus and so on till an. So A3 plus A4 plus A5 and so on an. If I
So
add
why
that,
we are adding, okay,
for
to
computing the
get the
limit, okay,
an.
yeah. So A3 is actually A2 plus A1 by 2. That is what we have, right? So I just added left hand side. So the right hand side, I will add the right hand side things. So this is A2 plus A1 by 2 plus A3 plus A2 by 2 plus A4 plus A3 by 2 and so on. I will have plus an minus 1 plus an minus 2 by 2. Okay. So now see, this is A2 by 2 plus A1 by 2 plus A3 by 2 plus A2 by 2 plus A4 by 2 plus A3 by 2. I can write it like this. So I'm just splitting this. A2 by 2 plus A1 by A4 by 2 plus A3 by 2, like this. If you see here, there is A2 by 2 term, A2 by 2 term, A3 by 2, A3 by 2. I will get A4 by 2 and some next term I will get A4 by 2. Correct?
Excuse me, sir.
Hmm.
How did we get A2 by 2?
Okay, I will take it on the new page. Okay.
Is that a midpoint?
No, A3, A4, A5, A6 and so on till AN. So this is the left hand side, and the right hand side we have A2 plus A1 by 2 plus A3 plus A2 by 2. So A3 is actually A2 plus A1 by 2. A4 is actually A3 plus A2 by 2, like this. A4 plus A3 by 2 and so on, plus AN minus 1 plus AN minus 2 by 2. So this thing I will write it like this. Just invert this in the numerator. I am inverting this. A1 plus A2 by 2 plus A2 plus A3 by 2 plus A3 plus A4 by 2. Can I write it like this?
Yes, sir.
Yes, sir. Yes, sir.
And the last term AN minus 2 plus AN minus 1 by 2. Now see, A1 plus A2 by 2. Can I write it like this? A1 by 2 plus A2 by 2.
Yes, sir.
Plus A2 by 2 plus A3 by 2. So this thing. A2 by 2 plus A3 by 2. I can write?
Yes, sir. Yes, sir. Like A2 is coming 2 times, A3 is coming 2 times.
And so on. Here also there will be A4 by 2 plus A5 by 2. Like this. And so on. Here it will be AN minus 3 by 2 plus AN minus 2 by 2 plus AN minus 2 by 2 plus AN minus 1 by 2.
AN minus 1 by 2, yeah.
Okay. Now you see, you combine these two, these two, these two,
and
these
we'll get
these two, these
simple
two.
A1 plus
half
A2
will
plus A3.
represent,
this will be like
half
A1
will
by 2,
give
yeah. Half will,
A2,
this will be like
half
A2
will
plus,
convert in 1.
yeah, 1. A2 plus A3 plus A4 plus and so on plus AN minus 2 plus AN minus 1 by 2.
minus 2. Yeah.
Okay. We will have only AN minus 1 by 2 one term. We don't have two terms. We will not have two terms. And also A1 by 2 only one term, one time.
Yes, sir.
Okay. Now see, you have left hand side A3, A4, A5 and so on till AN minus 1 plus AN. Okay.
Yeah.
This A3, can I
Cancel
cancel it out?
Yes.
A4, A4, A5, A5 like
Up
this
to
till AN minus 2.
Yes, there is one AN minus 2 also there.
Yeah, AN minus 2, this will cancel out. Now what I left with
AN equal to
minus 1 plus AN is equals to, we know the values of A1 and A2, it is given. A1 is 0 and A2 is 1 plus AN minus 1 by 2. Now see, so this is 0. AN minus 1 minus AN minus 1 by 2 plus AN is equals to 1.
Yes.
Correct?
Yes, sir.
Now this is actually AN minus 1 by 2 plus AN is equals to 1. Correct?
Yes.
Yes, sir.
Now see, limit, if there is a limit, we are convinced that there will be limit, right?
Yes,
yes. There will be limit value, right?
That is the first question. That's how you see that these are going to be midpoint by midpoint and midpoint by midpoint. But zero is very much in left side. Sir, how do we know that there will be a limit existing? This is much important.
See, if you keep on increasing your n value will come closer and closer to some value. Okay. So there will not be any difference between your AN minus 1 before term and the next term and the next term. So this will be something like 0, 1, half, 3 by 4 and this plus this by 2.
Yeah.
So it will be like 5 by 4, 5 by 8. Okay. And the next term will be like 6, 11 by 8, 11 by 16. Okay. And if you keep on, as your n keep on increasing, if you see the before term and the next term, the difference between those terms will be very less. Very, very less.
9 by
So if you keep on increase, like if your n value is very large, like let's say 1000th term, if you are looking at the 1000th term, it will be somewhere 1000th term and the 1001th term and the 1002th term. Okay, these three terms. The difference between these terms will be very much equal to zero, very much closer and very close to zero.
Yes, sir.
Understood? Yeah. So if you are convinced with that, then as limit n tends to infinite, an is actually equal to limit n tends to infinite, an minus 1. Can I say this?
What about an?
What about
an?
See, an we have that an is the nth term. An minus 1 is the n minus 1th term. As n tends to infinity, my n minus 1th term and the nth term values are almost equal, and those
Yes.
are actually
Yes, you are right.
the limit values.
Yes.
Can I say this?
Yes.
Yes, right. Understand this. This is slightly tricky to understand, but see,
Here,
we know that. Yeah.
Here, no rules, right? Just assumption. We are driving this.
Assumption. It's not about assumption. It's like if you have a limit. So you say, if you are convinced that
I
you
didn't
have.
get.
Okay. Suppose we say if you have a limit value for a sequence, this is the limit value. Okay. All the large terms will be very much close to these values. This value.
Yes.
Correct?
Yes.
So even if my n minus 1th term, before term and the next term, all the values are very much equal to this limit value. Okay. You know 1 by n sequence, right? Sequence 1 by n. So sequence 1 by n minus 1.
All are tends to 0.
Right? Here itself you see, if 1 by n is going to 0, where will 1 by n minus 1 will go?
Tends to 0.
Even this will also go to 0.
Yes, sir.
Okay. If this is a nth term, what is the n minus 1th term of this sequence? This is the n minus 1th term.
Yes.
If this is the nth term of the sequence, this will be the n minus 1th term of the sequence. So if you know that if you have a limit value, so your nth term and the n minus 1th term, when n tends to infinity, all these terms will be the limit values.
Yes.
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 So the limit n tends to infinity an is actually equal to limit n tends to infinity an minus 1.
Okay.
Okay.
But this is under the assumption that the sequence is convergent.
Sequence is convergent, yeah.
That's an assumption we are making.
Yeah, that's an assumption we are making from visual.
Sorry, is it given? I'm not sure. It's not. Is it a given? It's a question. It's given. It's a convergent.
No, it's not given. So that is what I said. It's like some understanding on limits you should have, or some visual understanding of limits. So where are these terms going? Are they diverging on the real line, or are they coming closer and closer to some value? So if you understand it, it will be in between 0 and 1. The limit value is between 0 and 1 in the first two terms. But the next two terms, it will be between half and 3 by 4. And in the next two terms, something like this. And it will go very much closer to one particular value. It is not an oscillating sequence. And also the nth term will not go to plus infinity or minus infinity. So those are the only two cases where limit does not exist. If it is not in the two cases, then we are guaranteed that the limit exists. Correct?
Yes, that's the difference.
Yes, sir.
So as n tends to infinite, this cannot go to infinite. This is guaranteed because it will be between 0 and 1. Between 0 and 1, all are real numbers. That is guaranteed, right? As n tends to infinite, an will not go to infinite.
So as the values are coming very closer and closer to the certain point,
the last nth value and the second last nth minus 12 value, the difference will be so small that they are considered to be equal.
Equal, yeah, as n tends to infinite. So as we are seeing the last terms will always be have the same. All the terms will come closer and closer to the limit value, right?
That part I understood. Without knowing the sequence, how can I actually say whether it's a convergent?
See, we know the sequence. We know, you know every term in the sequence. Okay, don't we know the every term in the sequence? We know every term in the sequence. The next term is dependent on the previous two terms. That's it. This sequence is yeah. This is a sequence, and we have given you the first two terms, and the third term is dependent on the first two. Likewise, fourth term is dependent on the second and third. So you know the sequence, complete sequence, you know. And this particular sequence, I know that this will not go to infinite plus infinite anyway. Okay. So that case is ruled out.
I have a question here. See the given sequence is by dividing by any numerator is divided by 2. Whenever any number will tend to infinity or anything like that, we have to divide it by 2. So if we cut 2, it will be 1. And denominator we will always get 1. And in numerator we will get whatever value we want. So by doing that, can't we say that this sequence will tend to 1 only?
This sequence will tend to 1. No. One value, you are saying that it will tend to one value.
Yes.
It will not tend to value 1.
No. It means I am saying the limit is 1 here.
How come limit is 1 here? So if you are saying limit is 1, then you are saying that as n tends to infinite, an will go to 1.
I am saying that.
No, sir. It won't go to
So
1.
he is referring the last line of your explanation, the next sheet. Yeah.
This one.
Yeah, this one is telling. Yeah.
Okay, one value, na? Not one value. So this thing you are referring.
Yes.
Okay, this is 1. So what is your question? Is it your question, or you are trying to explain something?
I was just asking, means can we think like this also?
What did you say? Can you come again?
I said that we have a denominator of 2, right? And in numerator, it will means if something as limit of n tends to infinity, then this numerator will become very huge number. But whenever we will divide it by 2, we will always get back 1 as a denominator. So can we say that the means there should be only one limit at this point? At any when n tends to infinity. Just my thinking process.
No, not that. Okay, see, for this thing, you should actually convince yourself by visually looking at the number line and looking at the terms. Our value as n tends to infinite, this particular sequence will tend to one particular value, and we are trying to find that particular value. Okay. So in order to find that particular value, we follow this approach, and we got till here. And if we are convinced that this particular sequence has a limit value, then the nth term and the n minus 1th term, just before the nth term, the n minus 1th term, both will have the same values as n tends to infinite.
The value will be so small, then it will become insane.
Yeah.
We can call it same.
You can call it. So as n tends to infinite, this particular an and an minus 1 will actually be equal to the limit value a. Okay.
Okay.
So now we know this. You just apply limit n tends to infinite, an minus 1 by 2 plus limit n tends to infinite, an is equals to 1. So this is like half times limit n tends to infinite an minus 1 is a plus limit n tends to infinite an is also a is equals to 1. So this will be like 3 by 2 a is equals to 1, a will be 2 by 3. So what is a? Limit n tends to infinite a, the limit value. Okay.
Sir, the unique. So we have done so far in our limits or limit section. Is this kind of questions to come?
No, don't worry. Mock will always be difficult than the original. Well, okay.
So this question is very complicated.
Yeah. It was slightly trickier question we gave in the mock. So whatever I discussed, focus on that more.
So, sir, if we want to increase the understanding of this kind of questions, what do you refer? Like, what should we do?
We have given you some. James Stewart is one nice book for calculus. Okay.
Higher algebra.
So if you are interested,
can you tell the name again?
Yeah, I just have written James Stewart.
Sir, this book is uploaded in the dashboard, no, sir?
I don't think. Is it uploaded?
So there is one calculus book uploaded that is also having these details.
Yeah. Even that calculus book we have.
Yeah, it is also having all the information which you are explaining.
Yeah. So you can go through that also.
So, but understanding from a book is a bit difficult for us non-maths background. So,
okay, we can do a few things. So it's like you will have a term break, right?
Yes.
So term between term break. So there we can have some sessions so those who are interested to learn, you can join that and we can discuss a lot.
Sir, I bought this book, but explain very nicely step by step.
Yeah, correct. So that was prepared by our instructor.
So one more thing in that question, can you explain what is the meaning of for upward, sir? Please.
What is the meaning of?
Like the sequence is given for n is greater than equals to 3. So what does this mean? Like what is
the first
the
two
use
terms
of
we
it?
have given you.
Yeah.
For the next
0
terms,
and 1.
for all the third and above terms, it will follow this particular equation.
Okay, so for first and second term, 0 and 1 will be there, and for the greater terms, we have to refer this one.
So it will actually take values dependent on the before two terms. So that is what it is.
Okay, sir.
Why we are adding A3 plus A4 plus A5 so on AN, sir, in the first place?
To get limit, to get to the limit value, to get the limit value. See, this is some, that is what I said, right? This particular question is somewhat a higher standard of limits.
Okay,
so you need to understand limits better. This is something higher. So we just gave this question because we just wanted to know how many of you can actually perform or think in this limit concepts.
Sir, like these questions will come in
no.
quiz to exam?
No.
That much easy level, I don't think so. It is only for the understanding.
See, mock will always be difficult. In any exams, mock will always be difficult than quiz, original paper. Okay. So mock, if you can able to solve mock, then you can be confident about yourself.
Sir, in the before this question, you said that limit n minus 1 and n is equal. That I understood, sir. But after that, 2 by 3 how it come?
2 by 3. Okay. just like it's just a substitution. This thing you got, right? An minus 1 divided by 2 plus this thing we got, right? We derived it
Yes,
from
sir.
above. So once you divide it, you just apply the limits. Limit n tends to infinite for this. So it will be like limit n tends to infinite an minus 1 by 2 plus limit n tends to infinite an. So it's the sum of two sequences thing. So you
How
can
it
write
is
it
one,
like
sir? Is
that is derived, right? That we derived from above.
okay, sir. Yes, sir.
You just go through this, that you will get. And from there, we just said these two sequences will have the same limit a. So just substitute a, and you will get a as 2 by 3. Okay. Okay. Let's come. See, I have discussed a lot on limit of a sequence, and those many questions are not even present in quiz 2. Okay. Let's come and discuss. There are lots of things to be discussed yet. Okay. Let us proceed and let us discuss these things.
Yes,
So now
please.
we have seen limit of a sequence. Now forget about sequences. Now we are dealing with functions. So when it comes to functions, we say if I have a function and we say the limit of this function at point. So we talk about limit of a function at one particular points, at each and every points. So the limit of a function at some point a x is equals to a exist. So for that we have to compute the left hand limit and the right hand limit. So we just have to see where will the function value will go when I come from the right side of a is called the right hand limit. Where will the function value will go when I come from the left side of a. So let us suppose say this is the function, some function, maybe x square. So I have function f of x is equals to x square, and I wanted to compute whether the limit exists at x is equals to 1 or not. So how should I check is, so if I approach from right side of 1, so that means from 1.5, 1.4, 1.3, 1.2, 1.1, 1.05. So I'm coming towards 1 from the right hand side. So that is what the right hand limit means. So you are coming from the positive side of a or positive side of 1 or the greater side of 1. So when you come from this side, where will the function value be? What is the function value? So as x tends to a plus, where will f of x tend to? So if it is going to some value, let us say L or HL, right hand limit value, some value. So here when I say f of x is x square, so here when I compute this limit x tends to 1 plus of x square, if I come from right side of 1, my x square will be like, my x square values will be like, if I take 1.5, it will be like 1.5 whole square, which is 2.25. So when I take 1.5, 1.4, you should come like this, 1.3, 1.2, 1.1, 1.05, 1.01, like this. So if I take 1.5, it will be like 2.25, 1.4, 1.96, 1.3, 1.69, 1.2, 1.44. So you see 1.1, it is like 1.21, 1.05, it is like 110. So 1.025, like this, 1.01, something like 101, 101, 101, 1 point, what is 1.01 whole square? 101 whole square, 1020, like this, 1.0201. Okay, you see, as I am coming, as the x values are coming from the right side of 1 like 1.5, 1.4, 1.3, my function value is also like 2.25, 1.96, 1.69, 1.44, 1.21, 1.025, and 1.0201. if I go closer and closer to 1, it will be like 1. So if I come, if I travel from the right side of 1 and if I come towards 1, my f of x will actually take value 1. So that is LRHL. So right hand limit. Okay. If that is the right hand limit, and if I come from the left side of A, so left side of A means something like 0.9, 0.91, 0.92, 0.93, 0.94, like this if I am approaching to 1. So the left side of, from the left side of 1. So you start from here and you come towards 1. So what will be the limit value of this function? So there are two limits now. So one is from the left side and one is from the right side. So one value is like LRHL and another value is like LLHL. So left hand limit and the right hand limit. So now that we have two values, we say if these two values are equal, if the right hand limit and the left hand limit values are equal, and if it is equal to some L, then we say limit of this function f of x exists at x is equals to a, and we write it like this: limit extends to a, f of x is equals to L. So the left hand limit and the right hand limit must be equal. If it is equal, then we say limit of that particular function at x is equals to a exists. And the other case is, what if these two are not equal? So something like if one is like 2 and one is like 1, which are different. Likewise in sequence also we have seen, if it is going to two different values, the limit of that particular sequence does not exist. Even here also, if one limit value is not equal to the other limit value, right hand limit and the left hand limit are not equal, then we say limit of this function f of x does not exist at x is equals to a.
Because we are getting two values here, right?
Two values here, yeah, two values here, and as x tends to a, we don't know which value to take.
Yeah.
Okay. So there it is not unique. Therefore, the limit of this particular function does not exist. Okay. And there are some standard limits which you have to know. Limit x tends to 0, sin x by x is 1. Okay. So now we are in functions. Now x can tend to 0 or x can tend to infinite or x can tend to minus infinite. In sequences, only case is n tends to infinite. That's it. Okay. Here, limit x tends to 0, sin x by x is 1. So this is, you have to remember. And this is one more important thing for differentiabilities. We actually use more of these things. Limit x tends to 0, e to the power x minus 1 by x is actually 1. Will actually tend to 1. And this limit x tends to 0, ln 1 plus x by x is actually 1. If you know L'Hopital rule, all these are easy to derive. Okay, we will deal that L'Hopital rule also. So these are some standard limits. You have, it is helpful. Yeah, this is about limit of a function at x is equals to a. I have a collective example. We will deal with that example. So before that, let us see continuity and differentiability also. So continuity of a function. So here also for continuity or for differentiability or the limits, we talk at one single point of a function. So the continuity of a function at point some x is equals to a is if the limit of f at x is equals to a exists. So firstly the limit should exist, and apart from that the limit value should be equal to the function value at that point. So the function value at that point is f of a, and whatever the limit extends to a f of x, which we compute the limit, that limit value and the function value should be equal. That means the left hand limit and the right hand limit both must be equal, and that value must be equal to f of a. Then we can say f is said to be continuous at x is equals to a. Okay. So limit along with the limit is one more condition.
सर function value के equal मतलब क्या?
Function value मतलब you just substitute x is equals to a in your function. So f of a is the function value at a. So if you have f of x is equals to some x square, okay. So if I talk about limit at x is equals to 1, so continuity at x is equals to 1. So the function value is actually f of 1. F of 1 is the function value, and this limit x tends to 1, f of x is the limit value. So this limit value will also be equal to 1, and this f of 1 is also equal to 1. So f of 1 is equals to 1, which is the limit value. Limit value and the function value are equal. So we say function. Yeah. So this is continuous at x is equals to 1. So for example, you see.
Sir, above example, x square.
Above example is okay. If I have mod x, okay, f of x is equals to mod x. And if I am checking the continuity at x is equals to 0. Okay. So first and foremost thing is I have to check the left hand limit and again the right hand limit. Correct? So when x is coming from the left side of 0, what will be f of x? So this is actually x when x is greater than 0 or equal to 0. This is minus x when x is less than 0. So when x is coming from the left side of 0, that means x values are taken from the left side, negative side of 0, something like minus 0.5, minus 0.4. So these x values are less than 0. So when x is less than 0, my function f of x is actually minus x. So this is actually equal to limit x tends to 0 minus x. So what is the value of this? Limit x tends to 0 minus, where will minus x go? So where will, so limit x tends to 0 minus x.
Minus 0.
Minus 0. Minus 0 is 0 doesn't have any sign. So it will go to 0.
0.
And when x is coming from the right side of 0, right side of 0 means something like 0.5,
1.
0.4, 0.3, 0.2,
0.
something like this. So in this places,
1,
function
sir?
is actually x. It behaves
So 0
like
again?
Yeah.
Yeah.
So it will be x and it will be 0. So the left hand limit and the right hand limit both are same. So the limit value
limit exists
at x is equals to 0. What is the function value at 0? F of 0. What is f of 0?
That is modulus of 0 again 0.
Mod 0, which is 0.
Yeah, 0.
Okay.
Yes, sir.
So the limit value, the left hand limit and the right hand limit both are equal to 0, and the 0 is same as the function value. So therefore we say at x is equals to 0, this particular function f of x is equals to mod x is continuous. Mod x is continuous at x is equals to 0 because it satisfies these both conditions. So these two conditions, limit exists as well as the limit value is actually equal to the function value.
Sir, a function to be continuous, we need 3 values, right, sir? LHL, RHL, and this f of z, f of a.
F of a, correct.
All the answers should be same.
All the values should be
same. Okay, sir.
Sir, if it is mod of x plus 1, it won't be continuous, right?
If it is mod of
x plus 1.
Inside plus 1 is inside mod or?
Inside mod, yeah.
Okay, inside mod also what changes?
Plus 1 will be there. So in this case, value will not be equal. That's my understanding. If I put x is equal to 0, so the limits will be.
I think, sir, it will be same.
Okay. I think
because
one answer is coming.
it is mod there.
Yeah.
Okay, sir. Okay, I understood.
Mod x plus 1. Okay,
Yes.
understood.
The
Understood.
graph will be shifted 1 unit right side.
Correct.
1
I
unit
understood.
left side.
Right side.
Left side. X plus 1, right?
Yes.
Yes, sir. Left.
Yes, sir. Understood, sir.
Yes, sir. Yes, sir. If it is, if we make it as equal to 0, then x will come out minus 1. That's why it shifts to
So
minus
continuity, if you know the graph of function, okay, no need to worry about continuity too much. You draw the graph. If you can able to draw the graph without lifting your pen, then that is continuous function.
Got it, sir.
So mod x can be drawn without lifting the pen. So like this you can draw. Okay.
But this is possible only for small graphs, easy graphs. But
Yeah,
for
easy graph.
complex graphs,
That is what I am saying. If you know how to draw the graph of any given function, any simple given functions, then by looking at the graph, you can actually conclude whether it is continuous or not. Okay. Okay. What is differentiability? So there will be one more condition. For limit, there is one condition. For continuity, there are two conditions. For differentiability, there will be one more condition along with continuity. So first and foremost condition is f should be continuous at x is equals to a. So f continuous means it should get these two conditions need to be satisfied first. So if f is continuous at x is equals to a and this particular new limit, this is something different limit than the left hand limit and the right hand limit. This is another limit. H tends to 0, f of a plus h minus f of a divided by a plus h minus a, which is denominator is actually equal to h. So f of a plus h minus f of a by h should exist. Again, should exist means the left hand limit and the right hand limit should be equal. So this actually means limit h tends to 0 minus f of a plus h minus f of a divided by h should be equal to limit h tends to 0 plus f of a plus h divided by f of a by h. Okay. So these two should be equal. Then we say this particular limit exists. If exists, then we say f is said to be differentiable at x is equals to a. If this does not exist, then we cannot say. Then we say it is not differentiable. For example, so whatever the example we consider just now, f of x is equals to mod x. Okay. So this particular mod x is nothing but x when x is greater than or equals to 0 minus x when x is less than 0. And the graph of this function is also like this. So I just wanted to check the different whether x is whether at x is equals to 0 it is differentiable or not. So in order to check that, I need to check limit h tends to 0 f of 0 plus h minus f of 0 divided by h should exist. That is the condition I should check. So in order to check that,
f of h by h will left
0 minus f of, so this is f of h minus f of 0 divided by h, and we know f of 0 is 0 for mod function, correct? F of 0 is 0.
Yes,
so
sir.
we will be left with limit h tends to 0 minus f of h by h, and for the right side we have limit h tends to 0 plus we have f of h minus f of 0 by h, which is actually again limit h tends to 0 plus f of h by h. Now see, as h is tending to 0 minus and f of h, so it's like if you are confused with h, you just see it is same as it's just the variable. Okay, this is like this. So as x is approaching to 0 from the left side of 0, so that means like this, minus 0.5, minus 0.4, like this. How is the function behaving? F of x is behaving
Decreasing.
Zero, sir. Decreasing.
Decreasing.
So what is this?
So y equal to minus x.
Minus x,
x
sir.
or plus x?
Minus x, sir. Minus x.
Minus x. F of x is equals to minus x when x is less than 0.
Yes, sir.
So here x values are less than 0. It is coming from the left side of 0. That means negative values.
Yeah.
So when it is negative, f of x is minus x. So that means limit x tends to 0 minus. This will be minus x by x. So this will be like minus 1. This value is minus 1. So you can do it from here also. No need to convert to x. From here itself, this will be f of h by h. F of h will be minus h. So limit h tends to 0 minus. This will be minus h by h. This will be equal to h and h will get cancelled and this will be equal to minus 1. What happens to the right hand side? So h is actually from the positive side of 0. So when it is positive
Plus
side
1.
of h will be h
H
only.
by H.
Yeah.
H.
So this is h by h. This is
1.
1. So now you see left hand limit and the right hand limit both are not equal.
So this
Yes,
is not
sir.
differentiable.
Yeah. So that means this particular limit does not exist.
Sir, how is f of h minus h?
F of h
Minus h.
May I?
See, f of h is minus h because h values are negative values.
Because
h,
sir हम लोग लिमिट नेगेटिव में ले रहे हैं
h
इसलिए
is
ना
coming from the left side of 0. Okay, h values are actually minus 0.5, minus 0.4, minus 0.3, minus 0.2, like this, minus 0.1. It is actually coming closer and closer to 0 from the left side, left hand side. So as the values of h are negative, so when input is negative, my mod x function is, if my input is negative, it will give me minus of it. So
Got
f
it,
of
sir.
h will be minus h. Okay.
Yes, sir. Got it, sir.
So as the left hand limit and the right hand limit are not equal, we say this particular limit does not exist, and we say once this is does not exist, we say f of x at x is equals to 0 is not differentiable.
Excuse me, sir.
Yeah.
Can we say like as the question defines minus x will goes x less than 0. If we take minus 1 minus x, then x will go less than 0. So can we say that it will go in the negative direction? So that's how from that also we can get the different values. Is that
No, not that.
okay? Okay.
See, in order to take this particular function value f of h, so we need to give some function value, right? What is f of h? So when what is f of x if x is greater than 0? What is f of x if x is greater than 0?
It will take x.
X, right?
But
If f of x is if f of x is x, what is f of h? H, right? F of h is h when h is greater than or equals to 0, and f of h is minus h when h is less than 0.
Yeah.
Correct?
Yeah.
So here, when h is coming from left side of 0, that means h is actually negative. H is actually negative. So what will be f of h now?
सर mod x माइनस नेगेटिव में पॉजिटिव वैल्यू देता है ना?
हाँ,
But
positive value.
still it is defining something कि
तो
अगर
सर हम लोग यहाँ पे इनपुट वैल्यू ले रहे हैं कि आउटपुट वैल्यू ले रहे हैं? मतलब y वैल्यू की x वैल्यू?
Output value. See,
सर वो
what
तो
is f
पॉजिटिव है
of
ना?
h? F of h is the output value, right? H is the input value and f of h is
लाइक सर मतलब जैसे हम लोग f of x लिखते हैं मतलब x की वैल्यू उस पूरे फंक्शन में पुट करनी है हर
Yeah,
जगह।
correct.
तो लाइक f of h मतलब h की वैल्यू पूरे फंक्शन में पुट करनी है तो वो हमको आउटपुट ला के देगा मतलब y वैल्यू।
Y value. So what is the
y
output
वैल्यू
when we substitute h inside this f of h?
तो वो h होगा लेकिन अगर हम माइनस h देंगे तो तब भी पॉजिटिव h होगा ना।
हाँ, see, यहाँ h क्या है? It is not 0. H is not 0. H is actually left side of 0. H is actually coming from the left side of 0. It is actually approaching to 0. It is not 0.
Got it.
अगर ऐसा आ रहा है तो when it is coming from the left side of 0 means h is actually negative. Okay, this input is actually negative. So if your input is actually negative, what will be f of h? F of some negative input. In order to make it positive, it will multiply minus to the input. No? See, just look at the function value. That's it. How the function is behaving for this value, set of values. So for negative values, this function value is actually negative, minus h. That's it we want, nothing else. How the function behaving in that particular interval. So this interval is h tends to 0 minus means some negative to actually 0. So this is the interval. In this interval, how the function is behaving. So this is the negative interval So negative interval means that interval falls in this case and the function value is minus h. Okay, if it falls in the positive side, then the function value is h.
ओ अच्छा, मतलब सर फ्लावर ब्रैकेट की वैल्यू लेनी है हमको। अगर ओ अच्छा, मैंने वो फ्लावर ब्रैकेट देखा नहीं, मुझे लगा था ऐसे लिखा है।
नहीं, फ्लावर ब्रैकेट का वैल्यूज लेना है। ओके
ओके, गॉट इट सर।
Sir, I have a doubt.
Yeah.
What is the graphical relevance of
what is the
graphical relevance of saying a function is continuous but not differentiable? Because if you give a function, then we can apply all these steps and you can
if
find.
there is a sharp turn, okay, you asked me that graphical.
Yeah, because seeing the graph,
seeing the
I
graph,
would want to know if, because I can see that some of the, see, this is like the standard example, but if I'm given some other graph,
okay,
I'm not able to say, I can say it's continuous or not, but I'm not able to say whether if it's differentiable.
If there is a sharp turn, so something like this. So this is not differentiable. So this point actually from till here it is okay, and at this particular point it is actually taking some sudden turn or sudden change in the behavior of the graph. Okay.
So that mod x
problem, yeah.
This mod x will not fall in the category of polynomial because there is a sharpness.
No, that is not polynomial. So these type of bends or sudden change in the graph behavior, these points are always not differentiable points because this will have two tangents.
Does it mean that from this point onwards it is unpredictable? Is it that meaning?
No,
So
this point will have
at
actually.
That point, it doesn't. It means that basically it doesn't have a single tangent.
Yeah,
a unique tangent.
Yeah, it will not have a unique tangent. See, basically this left hand limit and the right hand limit will give the tangents at that particular point. Okay, tangent slope at that particular point. Okay, this will be actually the f dash.
Sir, we have different slope for different tangent, no?
Yeah, we will have, if your values are different, that means when you are coming from the left side and when you are coming from the right side, you are going to have two different tangents with two different slopes. If you have more than one tangent, then we say that that particular point it is not differentiable.
So we cannot say what is the slope of that curve at that point.
At that particular point, which one will be the slope? Whether this is the slope or this is the slope.
That's why it is not differentiable.
That's why it is not differentiable.
Okay, got.
Okay, if there is a sharp changes in the curve, those points are not differentiable points. So something like these points also.
This can be related to instantaneous rate of change.
Yeah, correct.
Instantaneous rate of change, because
actually
we can.
The tangents actually refer to the term. Tangent, slope of the tangent actually gives you the instantaneous directions. So the tangents are actually the instantaneous directions.
And one more doubt, sir.
Sorry, dy by dx is not defined.
One by one.
So I'll complete mine because I
yeah, please.
dy by dx is not defined.
Yeah, dy by dx is not defined at this particular. You cannot write the f dash of x, which is actually the df by dx. So this is not unique. See, this f dash of x is not unique. You will get two different values, and we say it is not differentiable. Okay.
Shall I, sir?
Yeah.
Sir, in this example, by formula we have the denominator as h, no, sir? So when limit h turns to 0 negative, f of x by x, no, sir? So why don't we substitute 0 in the denominator, sir? X turns to 0 negative, no, sir?
It will cancel out, right?
It will cancel, sir, but usually we will substitute the value, no, sir? When x turns to 0.
If you substitute the value, if you are getting some determinant form, then that will be the limit value. If you are getting some indeterminate forms, maybe 0 by 0 or infinity by infinity.
That's what, sir. I will get 0 by 0.
If you get like that, what you should do? You should apply L'Hopital rule.
Okay, sir. Okay, sir.
Yeah. So, yeah, let's. I also shared this flowchart with the week 8 contents. So you can see the flowchart of this. So this particular flowchart actually gives you the idea or the connection between limit, continuity, and differentiability. Okay.
Can you also explain the floor and ceiling functions?
Not required.
Okay.
As of now. Okay.
Okay, sir.
Okay.
Sir, I have a question, sir.
Whether we can get this document in our link. Whether we can get this document in our link.
Yeah, you will get after this session. This particular PDF will be uploaded.
Okay.
So can you please explain?
Yeah, few are raising their hands. Yeah, Vishwajit Roy.
Yeah, sir, I have a question, sir, from sir, week 9 graded assignment, sir.
Week 9 graded assignment?
Yes, sir.
It will be highly difficult to discuss it here.
No, after class, sir.
After class,
No,
maybe
sir.
I will discuss. Okay.
Sir,
Yes,
please
sir.
continue.
Yeah.
Yes, sir, please.
Okay.
Sir, after
Yeah,
that,
see,
CT session.
Tangent, sir, can you please explain?
Is there CT session at 8 p.m.?
Yes, sir. Yes, sir.
Yes, sir.
Okay. I will complete it. So this particular flow chart has been given to you, and also I explained it in the previous session. So you can just go through this flow chart. It is very easy understanding flow chart, nothing difficult. It's the connection between limit and continuity and differentiability.
Remaining topic is linear approximation.
So yeah, I have one example. Let us solve this example, and linear approximation I won't deal. I will deal with the derivative function. Okay, we are left with only two main things. I will just complete it quickly. Okay.
So can you also do one example with the graph?
From
the graph.
Okay. We will
continuity and differentiability.
Sir, firstly complete this and after that.
Yeah. Okay. So how do we solve this particular question? So we said f is differentiable at x is equals to 0. When we said f is differentiable, that means it is continuous and limit also exists. Right? When it is differentiable, that means it is actually continuous and limit exists. So we need to find the values of m and p. So how do we find the values? So we will go step by step. We will try to get the left hand limit.
Sir, if it is continuous, we simply put the value, no?
If it is continuous,
we can put the value like
No, sir.
0.
Firstly, find the limit.
Firstly, find in order to find these values.
So firstly, find the limit. After that, find the value of that function at that point.
Okay.
Sir, n is equal to 5, sir.
Hello.
Yes, sir.
Yes, sir.
N is equal to 5, sir.
Still visible?
Yeah, visible, sir.
But stuck.
Now it's gone.
No, it's not.
Okay, just a second. I just lost the connection and I just came back. Okay.
So not visible.
Shall we do one more thing? Then
Yes, sir.
it will be difficult. Can we have one small tomorrow 1 hour session or something like that?
Yes, sir.
Sure, sir.
Morning.
No, sir.
Yes, sir, please, sir.
Sir, please keep it in the evening, sir.
But
It's not in the morning.
Morning around 8 a.m. 8-9.
Morning or evening?
No,
Sir,
evening.
sir, evening would be
Evening
good, sir,
will be
actually.
okay, 5 p.m. onwards, sir.
If you will have a doubt, we can ask. Sir, if you have a doubt, we can ask at the end, sir.
So same time of today, please fix it tomorrow, sir.
Yes. Please.
Yeah, that
Yes,
will
sir.
also work.
Everyone okay with that?
Yes, sir.
Okay, sir.
Yes, sir.
Okay.
Yes, sir.
Okay. So no issues because Sunday is the exam, right? Tomorrow is Saturday.
Yes.
Yeah, no problem, sir.
No worries.
No
If
worries.
you don't have any problem, even
No
I am
problem,
ready
sir.
to take.
So, sir, tomorrow which
I
time
have a
exactly?
time to early morning.
But early evening, please. Like
So
Yeah.
tomorrow which time exactly?
4 p.m. means like
Because
4
of
to 5.
because we have to
Sir,
we have to
8. So 7 to 8 is will be okay,
सर को
sir.
बोल लेते दो.
Okay.
we have to practice a question, sir.
So most of you are agreeing for tomorrow evening 6
Document
p.m.
report and that will be better.
6 p.m. is okay, sir.
6. Yes, sir. 6 p.m.
6 to 8 is okay, sir.
Yes, sir. 6 to 8 will
Not
work,
8.
yeah.
I won't take that long. Even I won't.
6 to 7.
Okay,
Yeah.
then 7 to 8,
Just
sir.
1 hour
7 to 8.
Sir, 6. Sir, from
6 to 7, sir.
6, sir. 6.
Sir,
Sir,
7 to 8, sir.
yeah, it's
7 to
okay.
8. I
No,
don't
no, no, no.
think
6
that will be
6 to
too
8
late.
because sir, early morning we have to wake up.
Yeah,
So
yeah.
that's it.
I know. So or else
Yeah, so center
I
is
can take it like 5 to 6.
Yes,
Sir,
yes.
it will be good, sir.
No problem.
6 o'clock
That
is
is
better, sir.
also okay, sir.
Sir, take your comfortable time.
No, not comfortable. My time. Your comfortable time. Because
early
5 to
morning.
6 will be good, sir.
सर
As we
मैथ्स की हर
said
टाइम कंफर्टेबल है.
before before 8 o'clock, sir, please.
Okay.
Sir, 6
Whatever
o'clock
it
better
is.
you start, sir.
Okay, let's fix with the 5 to 6 then.
Yes, sir.
Yes.
Okay,
Where
sir.
we will be
Okay.
getting the link.
Okay,
Sir, if
yes,
not,
okay, sir.
go for 5:30, sir.
If not,
5:30. Because I'll be reaching
Sir.
home at 5:30.
okay, then we will do it 6 to 7 only.
Thank you,
Standard
sir.
like 6 to 7. Okay.
Sir, where we will be getting the link? Sir, lecture link.
We will
Calendar?
provide you. Maybe calendar we will add the complete. May not be doing in Zoom, but we will do it in Gmeet or something. If possible, I will take the Zoom and I will also stream it on the YouTube.
Yeah.
But if it is not possible, at least I will take it on the Gmeet. Okay?
That is document.
So sir, how will we get this G-link?
In the calendar.
Calendar itself.
Okay.
Sir.
We will upload it in the calendar.
Sir, prefer Zoom, sir. We can see it in the
Yeah.
recording
I
section.
see 99%. I will try for Zoom link. Okay.
Sir.
Sir, please upload this document before that.
I will upload this document.
Where will we find the document? In the supplementary content.
In the
you will
supplementary
get that.
content.
Okay,
It will be in the supplementary content.
Sir, I have one question.
What about the document from revision 1, right? So it
It's
happens
also in the supplementary content.
Okay.
One more thing, sir, I want to say, like, we haven't yet, sir, we don't have week 5 to 8 slides.
It will be in resource from instructor.
Yes, sir. 5 to 8 slides we don't have. Yes.
No. You already have
Resources from okay.
It's already in the each and every week resource from instructor tab. You have each and every week.
Sir, in quiz 2,
Sir,
questions are coming for 5 to 8. Used to make
1 to
questions
8.
5 to 8.
See,
yes,
all
sir.
the questions will be related to week 5 to 8 only.
Sir, can I ask question now, sir?
Yeah. So please go and take some 3 or 4 minutes break and join CT session. I will take tomorrow session. Okay.
Sir, can I ask sir question?
Yeah. Please, you can ask me.
Sir, regarding sir graded assignment week, because I have a doubt, sir, because we after like 6th we have a deadline, so we have finished that class, and we didn't have after that we didn't get any chance to ask any questions regarding. So
okay. I will. If you are not attending CT session, I can take some 5 minutes time from you. I can explain.
Yes.
Sir, before that,
As we don't have CT, so
yes, sir. We also don't have CT. So can
we
we
have
continue
Python
here?
in this term.
Okay, those who have CT, you can leave and join the other session. Those who doesn't have the CT session, you can stay and ask some questions what you want. Okay.
Okay, sir. Thank you.
Sir,
Okay, sir. Thank you.
Sir, before we get into any topic, what are the things we have to give importance? Which are the topic we should practice more?
Whatever we discussed till now, even in the previous revision session and today's revision session, whatever we discussed, and tomorrow also I will discuss two topics. Main topics are, when you can do that. Main topic is how to get some values. If I say it is differentiability and the derivative of the function, you should know how to compute the derivatives of few functions.
so sir, tomorrow class at 5 to 6, right?
6 to 7 in calendar. If you follow calendar, you will.
Okay, sir. Thank you, sir.
So, sir, you are saying derivative and limits are more important.
Derivatives, limits, and this continuity, limit of function, continuity, and differentiability.
Okay.
Please share the answer of previous question you did.
Which one?
The value of M and P. M and
Answer.
Yes.
I have to compute. I have to compute and tell you. If you can wait for 1 minute, I will just tell you. So p value, m value will be.
Shall you screen?
Huh?
The screen.
So n value is 5. N value is 5. P value is 4. And m value is.
Can someone mute his or herself the very much background noise?
Okay, I will mute them.
Yes, sir. Thank you.
I cannot.
Actually, screen is not visible. Maybe you are not sharing.
I'm not
Okay.
sharing. I didn't get the access. I just asked them to make me co-host. So just write it somewhere. So if you have the values, if you have the question with you, the n value is 5.
Okay.
N value is 5 and the p value is 4. And m value is -3. M value is -3.
सर वन एक डाउट है, जो सर रिवीजन पहला सेशन है और जो ये वाला सेशन है और जो इसके बाद वाला सेशन होगा, अगर मैं उन तीनों सेशन को सॉल्व कर लूं तो पास कर लूंगा ना? एक्चुअली मेरा कैलकुलस बिल्कुल वीक है. मैं कैलकुलस बैकग्राउंड का नहीं हूं, इसलिए मैं पूछ रहा हूं कि पास कर सकता हूं.
I understand, but if you just ratta maar liya to we can't help. Okay,
but sir, at least we got the 40 passing marks from that. Is that
if you understand?
नहीं, मैं कॉन्सेप्ट की बात कह रहा हूं सर. मतलब जो आपने रिवीजन का कॉन्सेप्ट पढ़ा है, अगर मैं उनको सॉलिड कर लूं तो मैं पास कर लूंगा ना? मैं ये कह रहा हूं. रटने की नहीं, रट कहां पाएंगे?
मैथ्स इज नॉट एन
नहीं, वीक 6 तक सर मैंने हैंडल कर लिया था. वीक 7 8 के बाद मैं
अगर वीक 6 तक हैंडल कर लिया तो वीक 5 6
see Surya, you need to see 16 question. You will get 16 to 15 to 16 question.
No, only 10.
Sir,
10 questions, sir.
Yeah,
because last time we have received sir 16 question around.
Maybe subparts combine karke 15.
So if you like attend 8 questions out of your 16, then you will pass the exam, isn't it? So if 10 question is there, if we correctly complete 5 questions, then we will pass, right?
Sir, I have one question.
I think sir may not be liking this the way we are asking, only saying that passing, focusing on the passing. I think we should focus more on the percentage.
Yes.
नहीं, एक्चुअली सर मेरा पासिंग मोटिव इसलिए है क्योंकि एक्चुअली मुझे सीजीपीए तो मेरा नहीं बनेगा इस बार का, मुझे पता है. क्योंकि मुझे इस जो अगस्त का एंड टर्म कंप्लीट होगा उसके बाद मुझे अपना कैलकुलस मजबूत करना है. तो वो मुझे पता है कि मेरा पेपर इतना अच्छा नहीं जाएगा.
Excuse me, sir. May I ask something? Yeah. So, sir, I just want to revise quickly the last week 9 concept. So, can you help me?
Why are you revising week 9? Week 9.
Oh, acha, it is not there in the quiz, right?
Yeah.
Oh, okay.
Sir, can I ask the question?
Why you all like?
Yeah. Biswajit, you are waiting for a long time.
Yes.
Just ask.
Sir, actually, I have always doubt in sir Raymond sum, sir. Yeah, Raymond sir. Raymond sum, sir. So in that we have to do the partition, right, sir? How to do the partition? Actually,
I have always... the same query in Raymond.
How to do the partition?
Yeah, partition, sir.
So see, partition.
So for example, we have a graph, right? So for example, 0.0 to for example 0.6. So under that we have to calculate all the pie chart, right? So not pie chart, actually graph or the histogram, for example. Then how to like do the partition of that? We have like 0 to 2 or 2 to 4 or something. 4 to 6 or something like that, sir.
How to make is like, see, it's in our hand, okay? First
because
and foremost thing is
one questions I have I did the calculation, sir. So my calculations shows like 756 is the answer, but they have given 724. So that's why I did the calculation. Everything is correct, sir. But
Can you have that question and understand?
either their question will be wrong or my question, my answer, either their answer.
We will do it. Before that, I can see 30 people. Are these 30 people doesn't have session of CT?
Yes, sir.
No,
Yes,
sir.
sir,
No,
we
sir,
have
we don't have
completed
that.
CT
No,
and
Yes, sir, we have done CT.
now we have Python
Okay.
in this term.
Okay. You have Python students. Okay, it's okay. Are there any people who are still waiting that I will tell something and sitting here? That is what my question.
Python people, they don't have exams, sir.
No,
I know.
but we have stats also together.
Stats 1.
Stats 1, yes, sir. Stats 1, maths 1,